Let's talk about the polar coordinate system. We're very used to talking about and working in the rectangular coordinate system where we have two axes. This is our y-axis and our x-axis, and we plot points and they are labeled with the coordinates x, y. So for instance, if this were the point 3, comma 4, something like that, then this would be 3, 4. That would be that point. So this is the rectangular coordinate system. And today we're going to talk about the polar coordinate system, which uses distance and direction to specify the location of a point in the plane. So let's talk about some vocab terms with this. So we have the fixed point here. This is kind of like the vertex of this particular angle. This is called the pole or the origin. And then we have the polar axis. And if we were to set the rectangular coordinate plane on top of this, the polar axis is kind of where that positive x-axis would be, but it's a horizontal ray. It's coming out from that pole. And then we have a point up here, which we're going to specify just like how we had a point here, but we had coordinates x, y. The point here is going to be given the coordinates r, comma, theta. And r, it's going to remind you of the radius here. It's really the distance from the point of the pole up to the point. So r is the distance from that pole 0 to the point P. You're going to see in a minute that this polar coordinate plane is going to look circular. So a lot of times we're going to say this is the radius. And then theta is the angle between the polar axis and this segment OP, which we obviously create from the pole up to that particular point. So this is going to be theta here. So let's look at some examples and it's going to make more sense. So we want to plot these different points on this coordinate plane, and then we're going to give two other polar coordinate representations of the same point. One where r is greater than 0 and one where r is less than 0. And this is going to make more sense here in a minute. So let's just kind of work through a couple of these. So remember that your point is r theta. So here is your pole or the origin. Here is that polar axis. So that horizontal ray that goes out this way, this is your polar axis. And this is going to come into play when we're talking about what our angles are. And then each of these circles has a radius of 1 unless specified. So just like how on your rectangular plane, you could have every single tick mark worth 1, or you could have every single one worth 5. So this one would be 10. You can do whatever it is that you would need to do. So you could say each one is 1, or each one is 2, or 5, or whatever you need. So in this case, we won't label them, and that means that they are just equal to 1. So we need to have a point where r equals 1, which means the distance from that pole out is going to be 1 unit. So that's going to be along this circle, since this circle has a radius of 1. And then we have the theta is 3 pi over 4. Well, we know that 3 pi over 4 is along this line here. So along this line and 1 unit away from the pole, it's going to be right here. So this would be point A. Point B is 3 negative pi over 6. So this means the distance from the pole out should be 3 units, which means that we're going to be on this third circle. And then negative pi over 6, well, here's positive pi over 6. So negative pi over 6 means we're going to go in the clockwise direction, and point B would be right here. Oops, my pen is grabbing that. There we go. Point C is 3 comma 3 pi. So our angle, our theta is 3 pi. And again, we're going to be on that third circle. So here's our third circle. This would be 1 pi and then 2 pi, which means 3 pi would be over here. The next ones are going to look a little bit different. And if you notice, your r value is actually negative, which seems kind of strange because we talk about how that r value is the distance from the pole out to that particular point. But when your r value is negative, you're going to treat this in a different way. So what you're going to do is the negative 4, if we were plotting the point 4 pi over 4, we'd be able to do that by saying, okay, here's pi over 4, and then 1, 2, 3, 4 units away, the point would be right here. However, when it's a -4, what this means is you find your angle at pi over 4, and what you're going to actually do is you are going to cross over the pole directly in the opposite direction, the same number of units. So instead of 4 units out this way, you're going to cross over the pole to the opposite direction, and your point is actually going to be right there. So let's try it again with -5, 7 pi over 6. Well, if it were 5, 7 pi over 6, here's 7 pi over 6. So 1, 2, 3, 4, 5, it would be there. But -5 means we have to cross over the pole in the opposite direction, and we would land right here. Now, hopefully, just in doing those, you can see that these points that we just plotted, they could have other representations. They could have different coordinates. So for instance, this point E that we have right here, we just put it here, even though it was -5, 7 pi over 6, hopefully you can see how this could also be 5, positive 5, and then our angle would be pi over 6. So both of these represent the exact same point. Same thing, -4 comma pi over 4, that was right here. Well, if I wanted to use a positive r of 4, well, what angle is coterminal with this angle right here? What is this angle? We know this is pi, so if we're doing over 4, this would be 4 pi over 4, so this would be 5 pi over 4. So 4 comma 5 pi over 4. Just in the same way, we could take point C, which we got by doing 3 pi. Hopefully you can see how this could also be 3 comma pi, because pi and 3 pi are coterminal. Now, if I wanted to have this point have a negative r, like -3, then that means that we would need to use the angle directly across from it. So instead of pi, we could use something like 0 or 2 pi. So each of these points has an infinite number of other representations besides the one way that we wrote it. -5, 7 pi over 6. So again, where we have E here, if we wanted to write another one with a negative r value, we could say, well, what is this angle over here? How could I represent this in another way besides 7 pi over 6? Well, it's the same thing as saying -5 pi over 6. Up here, 1, 3 pi over 4, that was this point here. So if we wanted to keep a positive r value, we could say 1, and then we'd have to find another way to say 3 pi over 4. So you could add something like 8 pi over 4, since that's 2 pi, and find something coterminal. So that could be 11 pi over 4. Or you could have said 1 comma, and then if you think about going this direction, -5 pi over 4, that could also work. But if we need a negative r value, because I wanted one where r was positive and one where r was negative, we could use -1, and that would mean that we're talking about this angle over here, which we know if we're looking at positive angles, positive theta, that could be 7 pi over 4. So -1, 7 pi over 4. These are just examples. You could have different situations. Point B here, we got from doing 3 -pi over 6. This could also be 3 and then 11 pi over 6. If we wanted to have a negative r value, well, then we'd have to look at the angle directly across from it, which is 5 pi over 6. Or you could use anything coterminal to that. Last one, we need a negative r value for point D. We already had -4 pi over 4 for this. So if we wanted to use -4, we'd have to have something that's coterminal with pi over 4. So we could say something like -7 pi over 4, right? Because pi over 4 minus 8 pi over 4, we could have -7 pi over 4. Or you could have said -4, and then if you added 8 pi over 4 to pi over 4, that could be 9 pi over 4. So lots of different options.